Welcome, and may the force be with you. Okay, today we're going to talk about balanced and unbalanced forces and how they change motion. Before we get started, we're going to do a couple of definitions here. First of all, a force is a push or a pull in any direction. A force is a push or a pull in any direction. And while we work today, I'm going to play some scary Halloween music. It's kind of in the background there. Okay. Balanced forces. Balanced forces occur when the net force equals 0 or the object, I don't know what's happening with this music, it's terrible, or the object is stationary or in constant motion. So balanced forces occur when the net force equals 0, which causes the object to be stationary or in constant motion. Okay. Unbalanced forces occur when the net force does not equal 0 and it causes a change in motion or velocity. We're going to talk about velocity next week. So unbalanced forces occur when the net force doesn't equal 0. There's a change in motion or velocity. Oh my gosh. My dog is whining that she needs to go outside. One moment, please. Look. There she is. Okay, let's let her out real fast. Oh my gosh, I'm so sorry about that. Okay, let's get back to business. Okay, a net force is the total overall force acting on the object. So the total overall force. To find the net force out here to the side, we're going to write, to find the net force, you have to add or subtract, and then the object's going to move in the direction of the greater force. Okay, and friction. Friction you know about. In elementary school you learned friction is like this. Friction is the force that opposes motion. So we're going to write a force that opposes motion. When you hear the word opposes, think of opposite. It goes against each other. So something that opposes motion is going to go against the motion. Okay, and then it says draw a picture of what friction looks like. So if I have like a box sitting on the ground and I've got someone pushing the box from one side, friction is going to be coming from the carpet in all directions. So we're going to draw some arrows underneath. It's coming in all directions. Okay. Alrighty. One more thing we're going to add up here to force is a force. Oh, you need to remember that forces are always acting everywhere. Forces are always acting everywhere. Okie dokie. Moving on down to our examples. We've got 3 examples here. So we're just going to fill in some numbers on these arrows so we'll know just how much force is being applied on each side. For the first example, we have 5 newtons pulling the box to the left and 5 newtons pulling the box to the right. So we need to find the net force. The net force, remember, is the total or overall force. If the forces are going in opposite directions, if they're not working together, then you're not going to add them together. You're going to subtract. Same thing down here, you're going to subtract. Let's go ahead and bracket these ones off here, and we're going to put different directions means you subtract. Different directions means you subtract. So down here, these are going in the same direction, so we're going to do the opposite. What would we do? We're going to add. Very good. Same direction means you add. Okay? Okay, so back up here. 5 newtons to the left, 5 newtons to the right. So they're going in different directions, so we're going to subtract. 5 minus 5 is 0 newtons is the net force. Now, let's even add a little bit more. Let's go up here back to our definitions. If the net force is 0, that means the forces are balanced. Let's write that out to the side too. Balanced. Okay, so describe the motion. Well, is there motion if there's 0 newtons? No. So the object is stationary. What does stationary mean? Stationary means the object is sitting still. It's sitting still, it's not moving. Okay? So think about what this one, it would be like 2 teams playing tug of war. And if they have equal amounts of people pulling with the same amount of force on both sides, the rope's not going to move. There's not going to be any motion. Okay? All right, then down here, let's do 5 newtons moving to the right, 6 newtons moving to the left. So once again, they're in opposite directions, so we're going to subtract. So 6 minus 5 is 1 newton. Very good. Now this time there is going to be motion, and remember up here we said it's going to move in the direction of the greater force. So which is greater, 5 or 6? 6 is greater and 6 is moving to the left. So the net force will be to the left. So describe the motion. The object will accelerate 1 newton to the left. Okay, and back up here again, our net force was 1 newton, so if our net force is not 0, they're unbalanced. So let's write that. Okay, our last example, let's do 5 newtons to the right and 5 newtons to the right. These ones are always the easiest. I always like it when I see them going in the same directions because I know I can just add and it makes it really easy. So 5 plus 5 is 10 newtons, and it's going to go in the direction of both forces to the right. So we're going to say it will accelerate 10 newtons to the right. And once again, our net force is not 0, it's 10. Our net force is 10. So that is unbalanced again. All right, so now down here, I want you to write different amounts of forces in each of these arrows. I'm going to make it simple. 2 newtons, 4 newtons, 6 newtons, 8 newtons. You can write whatever numbers you want here. Any number from 1 to a trillion, billion, quadrillion. Okay, so just fill those in, and then you're going to take your scissors and cut on the dotted line, like it says there, and then cut each of these forces out. So now you need to, so here's my forces. I want you to swap forces with two partners. Okay, so you're going to swap forces with two partners, and then you're going to tape your new forces in your ISN. So let's say I'm going to keep these two forces, and I'm going to swap these two with a partner. So then my partner is going to give me their two forces, and I'm going to find the net force working here. So now I've got my four forces, and you can put them in whatever order you want. So I'm going to do, so draw an object in the middle, and you're going to tape these puppies down. Okay, so then I want you to solve the net force with your partner. Remember, different directions, we're going to subtract. Same direction, we're going to add. Okay, good luck.